Hi. What we'll be showing here is how database records get transparently processed by our database middleware. The window we have open here is a commercial database client that is connected to an actual MySQL backend. We can see that we have two tables in this database, and we can also see that they are currently both empty. Over here, we have a terminal window running an unmodified MySQL command line client. Right now, this client is connected directly to our middleware, which itself is connected to the backend shown in the previous window. If we run a query over here, we can see that it returns no data as expected. We will be using this terminal to simulate the interaction between a developer application and their database backend through our middleware. The first thing we want to do is import some records. This would be a step that any developer migrating from an existing database would take. The data will get automatically encrypted before it is handed over to the backend for insertion into the target database. The file we'll be importing is this one. As you can see, the file only contains standard SQL insert statements. So let's import the data now by sourcing the file from the terminal. With that done, let's take another look at the commercial client connected to our actual backend. We can see that the tables are no longer empty and now contain the records we just imported. For instance, in this users table, we can see that all the string columns containing sensitive information, username, phone number, and address, are encrypted and unreadable with this connection. The same goes for the accounts table, where we see the value of the email column has been encrypted as well. However, if we go back to our terminal window and query those same tables, we can see that the data is fully readable here. The encrypted columns are all decrypted by the middleware before being routed to the client. Note that we can also use standard SQL queries, which work the same as if connected directly to the database. As an example, let's run a more complex query. We can see that this query also succeeds without any issues. Now that we've seen how records are imported, let's take a look at how communications are managed by XQ. This is our XQ dashboard. Right now, we are currently signed into the same team as the middleware. If we refresh the communications page, we can see logs for all the records we just added a short while ago. We can identify which log belongs to which record by the resource subject, which corresponds to the unencrypted memo columns of the inserted records. It's important to note that while we chose to define the subject this way, a developer can set it to whatever they want by simply defining a variable in their connection session before they insert the record. The same applies to the labels you see here. In our configuration, we have labels assigned based on the containing table. However, labels for records can also be set by the developer before they insert the associated record. Now, if we drill into an entry, we can see more information about the record, including the location it was read from and users who are allowed to access it. Because the encryption keys are being managed by XQ, we can also control access permissions to the added records directly from the dashboard. Let's take a look at an example with a data access policy. The policy shown on screen is one that prevents the encrypted fields in the accounts table from being read by local clients. In place of the record, the message in the notify action is going to get shown to clients who satisfy these conditions. So let's enable it and see what happens. Now let's return to the client and run another query on the accounts table. We can see that the encrypted column is no longer readable by the client. Revoking keys will have a similar effect. Once a key is revoked, all fields that were encrypted with that key are no longer readable in clients. The developer has multiple options in how they communicate the status to the user, but in our configuration, we simply display revoked in the field. Let's try that now. We can see that the record in our results now show revoked in place of the content. In general, the XQ database middleware is a system that allows developers to encrypt and audit their database content with little to no additional development time, just by connecting to the middleware and letting it do all the work for them. Thanks for your time. Questions and feedback are always welcome.